Okay, from waste to food. Have you seen? There's also the Cradle to Cradle workshop with Michael Braungart.
It has become a lecturer.
It's the afternoon of the 15th of April. So I think that's also an interesting one.
Yeah.
If you have time,
We're
I
here.
suggest to go there.
We're in Alma.
I think it's in the Oostcelle. But you see
The
it
orange
will be
thing.
also on the information screens. So there will be also lecture
also
by
debated.
Peter Leskier, and Peter Leskier is also on topsoil, so they will discuss also issues I discussed or presented. But maybe give add another perspective. Because Michael Braungart, you know this book, Cradle to Cradle?
Yeah.
He's actually a chemical engineer and was head of Greenpeace, so he's really, he can talk very good, sometimes a little bit too plakativ.
Yeah.
Good to see that. Okay, yeah, what is waste? A little bit following up the last presentation on, let's say, human waste. I just put a picture here where you can see some testing from Africa, where they have grew corn without urine or without any additives, and then more smaller or higher amount of urine as a fertilizer, and there you can see that it's really good fertilizer, so significant effects if you use it. So it's actually no waste. I just started talking about soil and topsoil, and also in the movie they discussed the soil aspects, that the use of pesticides are affecting or destroying the livability of soil. And what also happens through, let's say, conventional agriculture is that if you open the soil, that the soil, the carbon which is in the soil will go to the air. In the Netherlands, that's, and this is just by oxidation of organic material. So the peat soil in the Netherlands, for instance, is also, it's almost all organics. So if this lies open, it contributes to a very big amount of CO2 emissions. So, like Peter Leskier said that, if I remember it right, that the CO2 emissions by oxidating peat soils in the Netherlands are higher than from the cars. So you can imagine how big the influence of, let's say, soil erosion or oxidation is to the so-called greenhouse effect. And as you see here, it's stated that between 1750 and today, the land use change and the CO2 emissions by soil contribute to 30% to the global warming or to the total CO2 emissions. So it's really a significant amount. And another thing is that the soil are degraded also by soil erosion to a much higher degree than they can be replenished. So the soil is really a big problem. It's not only the fertilizer, what I mentioned last time, but if we don't have a good soil, we can't grow the food anymore. So the question is, how can we enhance the soil quality for future survival? In the movie, they discussed they mentioned some methods like composting and, let's say, work on the enhancement of soil. But of course, this is quite blurry, and this is what they mentioned. We can process organic material and bring it back to the soil. This is one possibility. But in the movie, which I will mention here, what you can watch at home, or maybe after this lecture I can put it on, and then you can maybe watch it at home. And they also discuss other possibilities which are regarded as much promising. What is important or good to mention is that organic materials can be not only composted or processed to bring it back to Earth, but they can also be processed to create energy. That was also mentioned. You can burn it or produce biogas, or you can also produce charcoal from it, biochar. And this is a very important ingredient to also reactivate the soil. And this is the movie, The Secret of El Dorado. It's a BBC production where they talk about what happened in the Amazon, that really 10% of the Amazon was urbanized, and how they managed to have cultures or permanent agriculture over thousands of years in this tropical climate. So it's really good to learn from that. That was the guy, the Spanish guy who went there and do you see that? And they saw this soil, so I can go through it because you will see it in the movie. So they discovered that at the left side is this black soil. It's very fertile still today, and right is the original tropical soil. They found out that in principle the soil is the same, but by human intervention it became this very black soil. And you can see you can find meters of this soil. They're all mixed with human waste, animal waste, fish bones, and relicts of pottery. And then they found out that these pottery they found maybe were not only for cooking, but this pottery was actually used to produce this kind of black soil. And so in the movie you will see they only describe the whole history about discovering the culture and this really magic soil, but you will not see, so they didn't solve the secret when they produced the movie. But recently scientists found out how they did it, and now there's even the first company who produces the black soil in Germany, Palaterra, to start a business with that soil. And it seems to be that this pottery was a kind of fermentation container. And you see very big units in the soil, filled with black soil. And this fermentation process, from sauerkraut, zurkol, or the Korean kimchi you see there. It's also in principle, the Asian or Korean way to produce hot, spicy zurkol. And at the bottom of the left, what they produce for the cows, so that they mow the fresh grass and then wrap it in plastic. It's the same process. This is milk acid fermentation. That's actually the chemical reaction you create. And when you go to the organic shop, also here in Delft, and then you look for EM, effective microorganisms. It's one guy in Japan. He developed it and started worldwide network producing these effective microorganisms and use them for the production of bokashi. That's a process which you may confuse with composting, but it's actually not composting. So you can buy also here in the Netherlands, you can buy these buckets and then you can put your organic waste there and add some of these EMs, the effective microorganisms, and then you trigger this milk acid fermentation process. And by this process you will create some liquid, so you can use this liquid then to give it to plants as a fertilizer. And after the fermentation process, you can mix it with the soil. The interesting is that with this fermentation process, you will have no gas emissions. So by composting, you have, let's say, again, CO2 emissions because it's kind of degradation. Or other processes without air, you produce biogas. So if you have something in a bucket, then the top will flow away if you don't have a good ventilation system because there's a gas production process. And with this fermentation, you don't have that. And that's quite interesting because this is now also applied in new sanitation concepts. So you may recall that I presented last time the compost toilet and the separation toilet. But if you think about solutions at home, that you have, let's say, a hut, a house, or emergency situation, where you put a toilet, it's generally you need a good ventilation system because otherwise you have a creation of smell. Even though by the right separation maybe less. But if you apply this Bokashi method to the toilet, then you can have a toilet with a cover, with an airtight cover, where a fermentation process takes place in the toilet, and when you lift the cover to make your next deal, business, you will not have a smell which blows you away, but you just can open it and sit on it and close it again. And afterwards the content can be used for soil fertilization. If we think about biomass and the production of, let's say, energy for cooking, but multiple use of wood, for instance, because in developing countries mostly wood is used as a fuel. And you have also to produce charcoal for this black soil, which is also added in the toilet, for instance, because the microorganisms and the nutrients will stick to the charcoal because the charcoal has a very, very big surface area. This is why you use also activated carbon, for instance, for water purification or for air purification as a filter material. Because if some matter goes through that charcoal, let's say all particles will stick to this very big surface. That means that it's like a universe for microorganisms and the nutrients to stick on that charcoal. But if you want to produce charcoal in an area where you have not much wood, then you can use pyrolysis cookers. I just put here the link, so you can also Google it. You can even build them by your own. So this is a model made from old metal sheets. And the idea of pyrolysis is it's a kind of wood gas. That means that you have a unit where normally the fire burns from down to upside, and then you have the emissions on top. And in these pyrolysis cookers, you have in principle two layers, and you lit, let's say, the fire on top, and when it starts burning on top, then the gas will be sucked to the bottom of the container and move up again. And on top of your wood, the gas is actually burning, and so the timber is reduced by a gasification process. And depending on how you adjust that process, you will get more energy out of your wood. So it's a very effective process of burning, and you will get as a result charcoal. So if you have a double effect, you can cook your meal with the wood, and you will have charcoal at the end. In the Amazon, you will see that in the movie, for their soil production, they produced charcoal actually with a quite traditional process, big piles of organic material and then covered with earth. So it's like the majority